All right, so as we try to build factoring fluency, we're going to be looking at a variety of different mixed factoring problems. So that's our topic for today. So our first rule of factoring is always look for a GCF. So if I look at this first problem and I look at that first term, that 36x to the second power, and then minus 27, I'm thinking of the biggest number that they share in common. And they're both divisible by 9, but that's really it. So I'm going to divide out a 9. And then I'm thinking, well, what's 36x to the second power divided by 9? Well, that would be 4, and then x to the second power. And then here, that 27, I know it's going to be a minus. What's 27 divided by 9? Well, that's just 3. Okay, and when I stare at it, I just want to think, is this fully factored? Well, yeah, because all I had to do here was pull out a GCF. Every once in a while, we give you one where we have a GCF, and then there's more factoring that happens afterwards. Okay, this next one, number 2, there's no GCF, right? There's nothing that they share in common. But I see that there are 3 terms, and that leading coefficient on that first term is really just 1. So I think of this one as a basic quadratic trinomial. And that leading coefficient is just 1. So in this one, I'm really thinking, what multiplies to a negative 21? It's always the a times the c that gets multiplied. And when the a is 1, it ends up looking like it's just the c, but it's really 1 times that negative 21. So what multiplies to negative 21 that adds to a negative 4? Now, sometimes it's easier to visualize it. So the product, that 1 times that negative 21, so negative 21, that sums to a negative 4. So when we think about it, well, 7 and 3, right? It's got to be 7 and 3, but which one is the negative, right? One of them has to be negative to make a product of negative 21, but they have to add to a negative 4, so it must be the negative 7 times that positive 3. So my factorization here would be x minus 7 in parentheses times x plus 3, also parentheses. All right, next up. Now, in fairness, this one is also a perfect square trinomial, but I recognize a pattern here because that first term is a perfect square, and so is the last term. Right? This is really x as a quantity squared, and this is 4 as a quantity squared. Now, what I recognize is that if I multiply the x and the 4, that's 4x, and then if I double it, that is what's in the middle. So that ends up being a perfect square trinomial. I'm just writing the words so that we get used to what it's called. So a perfect square trinomial. The structure here is when we think of something as x squared plus 2xy plus y squared. That factors into a binomial squared, a binomial times itself. So this makes x plus y as a quantity squared. So when I look here, all I do is I take the x, I join it with the 4, put a plus in the middle, quantity squared, just like that. So if I can recognize something as a perfect square trinomial, I can factor it really quickly into x plus 4 as a quantity squared. Okay, this next one here, I see a negative 1 out in front, and I give these a lot as a reminder that you have to treat that as a GCF. Factor out that GCF first. So if I divide out a negative 1, now I have x squared minus x minus 42. So now when I stare at what's left, I see, ooh, that's a basic quadratic trinomial, just like we saw directly above it, where now we have a leading coefficient that is 1. A is 1. So now I'm thinking of what multiplies to 1 times negative 42. So negative 42. I need a product of negative 42 that adds to negative 1. So these numbers have to be right next to each other. They have to be consecutive, one apart, but one of them is negative and one is positive. So I know it has to be 6 and 7, but which one is going to get me here a sum of -1? Well, it must be the -7. So fully factored, don't lose that negative out in front. That's -1 times the quantity of x plus 6 times, in parentheses, x minus 7. That is fully factored. All right, next up, here we only see two terms, right? We see two terms, and we see a perfect square and a perfect square. There was no GCF to factor out first. So what I recognize is that this is that difference of two squares pattern. So that first term is really 2x in parentheses squared, and then 121 is 11 squared. So once I recognize that it's two terms and they're both perfect squares and it's a difference, a subtraction, then I can rewrite that as 2x minus 11 in parentheses times 2x plus 11, right? And then also in parentheses. And now I can box it. It really doesn't matter which order you put them in. This one could have come before this one or vice versa, right? I just need to see this factorization, those two factors. Okay, in problem 6, here I see that there is a negative x to the 4th power that's coming first. So I have to remember to treat that as a GCF. GCF first. So divide out a -1, and we're leaving behind an x to the 4th minus 16. So now when I stare at that, I recognize that, oh, that's still a perfect square. So is that. So this is really a difference of two squares. I can recognize that x to the 4th is really x to the 2nd power squared, and 16 is 4 squared. So next stage I can say, well, -1 times x squared minus 4 times x squared plus 4. Okay, and I really want to be done, but I'm not done because right here is still a difference of two squares. So I think of this as a difference of two squares times 2 because I have to break down that pattern twice. This is still a difference of two squares, but there's no sum of two squares. So this part I need to factor down a little bit more. So I still have that -1, and now I have the package of x minus 2 times the package of x plus 2. But again, that sum of two squares, it stays behind. There's nothing more to do with that. Okay, and then I'm ready to box it. Now again, the order that you write these factors doesn't matter. I could have put this one first here and then the other two behind it. What does matter is that that -1 does go first. Okay, next up, so in this one I don't see a GCF, but I do see that it's 3 terms, so it's a trinomial, and I see that it's more complicated because I don't have a 1 out in front. So I think of this as a more complicated quadratic trinomial. Because that a value is not 1. Now some kids are really good at guessing and checking, and that's fine. We actually prefer it. But if you need a method, I'm going to remind you how we can use grouping to get to this factorization. So first thing, I'm just looking at, remember that this is the A, the B, the C, right? When we're looking at it in this structure of ax squared plus bx plus c. So when I think about the product, has to be the A times the C. So 2 times -12 gets me -24. And then the B, right, that's my sum of 5. Sum. So I need to find two numbers that multiply to -24 that add to +5. Right, it's got to be 8 and -3. Now here, since this is more complicated, we really need to think of what we just found here with an x, and then plugging in for that 5x right here, because 8x minus 3x makes us 5x in the middle. So if I rewrite this, I have 2x squared plus 8x minus 3x minus 12. And then I'm getting ready to try grouping to get to my conclusion. So here, again, this would consolidate and get me back to the 5x in the middle. So if I want to group it, though, I want to group my first two and my last two terms, and then I'm looking for a GCF right here. So they share in common a 2x, leaving behind an x plus 4. And then over here, I can factor out a negative 3, leaving behind an x plus 4. So now I can rearrange it, regroup it, because these two packages match. I can rewrite it as 2x minus 3, right, in parentheses, times x plus 4, also parentheses. There's my factorization right there. Now, if you're good at guess and checking, we're fine with that too. Okay, this next one, 8, it also looks like a more complicated quadratic trinomial, but the a value is not 1, right? It's 9 here. But when I stare at this a little bit more, I recognize that that first term is a perfect square. That's 3x as a quantity squared, and so is the last term, right? That's 2 squared. So I see that if I take that first and last term, if I multiply them and then double it, it gets me what's in the middle, right? If I multiply that 6x, and if I double, there's that 12x in the middle. I just have a minus here instead of a plus. Last time we saw that as a plus. This is the other variation of a perfect square trinomial. So it can be in this structure of x squared minus 2xy plus y squared. When we factor this, it becomes x minus y as a quantity squared. So here in my example, I'm going to have a 3x, and here's my 2 in parentheses, but there's going to be a minus in the middle, and then quantity is squared. All right, 2 more. Okay, lastly here, it's really about reformatting. So here we see that we have x times, in parentheses, x plus 1, minus 9 times, in parentheses, x plus 1. So all we're doing is we're just regrouping it. We're going to rewrite it in an equivalent structure, right? Because these two packages, they match. So I can rewrite this now as x squared minus 9, in parentheses, times x plus 1. Okay, these mean equivalent things. If I look back to here, imagine that I was putting this in standard form. I would distribute that x squared over the x and the plus 1. I would also distribute the negative 9 over the x and the plus 1. Well, that's the same thing when I look at it in that factored form here, because let me just cover this up. If I'm foiling it out, I'm going to multiply that x squared over the same x and the plus 1, and same with that negative 9. So now I've regrouped it, but I see that there's more to do because this right here is a difference of 2 squares. Right? Perfect square, perfect square. So this factors into x minus 3 times x plus 3, and then here's the other x plus 1. Okay, this last one here, we see that it's actually cubic, and it's a polynomial because we have more than 3 terms, right? Any polynomial could be any amount of terms, but we usually think of it as more than 3. Right? Because we know that a monomial means 1, binomial means 2, trinomial means 3. So here we see that we have 4 terms. All right, so I don't have a GCF. I just have 4 terms. So the only way that we can break this down further is by grouping. So same idea. We group the first 2 together and then the last 2 like this. And then here I look for a GCF. They share an x squared in common, leaving behind an x plus 4. Okay, over here, I can divide out a -1, leaving behind an x plus 4. They match as they have to be able to break it down further. So now I can rearrange it and write it as x squared minus 1 times x plus 4, right? All in parentheses like that. And then I see, oh, difference of two squares. There's more to do. So difference of two squares. This breaks down into x minus 1 times x plus 1, and then times x plus 4, just like that. All right, so hopefully good blended practice with factorization. Have a good day.